Hi guys, I hope you all are doing great. Welcome to the fifth video of Module 9. Here we are going to talk about the importance of having strides and padding and what kind of strides and padding to choose in different types of scenarios. Let's get started. So now let's talk about the importance of the strides. So when the strides is set to a small number like 1, we can encode a more detailed representation of the image because of the more number of convolutions. But on the other side, if the stride value is set to a higher value, let's say like 3, 4, we can encode with less time to compute, but not a detailed encoding. Because if I show you one example of, let's say, stride is equal to 2, initially a 2 by 2 filter was placed over here. And if it's a stride of 2, the next time it's going to shift towards 3, 4, 3, 5, as you can see over here, not 2, 3, 2, 3. It's now on 3, 4, 3, 5. So you are completely losing onto this 2, 2. Just like that, if the value of stride was 3, it would directly come down because there is no place going towards the right. So you're skipping a whole lot of part of the image. So you need to be really very sure about what type of stride you want to use depending on where are the features or the important features present in most of your training images. If the features are randomly scattered, at that time you can go with a higher value of stride. But typically you can choose something like 2 or 3, nothing more than that. Okay. And then if you think that the features are very much closer to each other, in that case you cannot use a bigger stride value because in that case you will be skipping a lot of information. So this was about importance of strides. Now let's talk about the importance of the padding layer. Now there are two major reasons because of which you might require padding. It's not compulsory you need them, but depending on the task that you are dealing with, you can go ahead with the padding. Now two problems that it solves, out of which I have already explained you the one, that is, if you are not having any kind of padding and still doing the convolution process, that is input image you are having and you are convoluting it with some kind of kernel or filter, the output image will always be smaller as compared to the input image. That's one problem. What is the second problem? While the convolution is happening without the padding layer, we are always going to miss out on this corner pixels. The corner pixels are not going to be given a lot of importance as compared to all the other type of pixels present in an image. So to avoid both of this, you can use a zero padding pixels, and maybe even if you don't really want to go with the zero padding pixels, you can go with the reflection that you are having. Let's say for example over here, you can reflect the 0, you can reflect the 9, you can reflect the 2, so on and so forth. You can also go with the reflection, but you can also go with the zero padding pixels. Over here you can see that initially the image was a 4 cross 4, but after implementing a padding it became 6 by 6 because we are introducing two new more pixels on either side. So from 4 cross 4 it went to 6 cross 6. So eventually you are still reducing the output size, but now the input size was a 4 cross 4 image. That was a complete image on top of which you have added a padding layer. So in a way, because the input size was 4 cross 4, the output is still 4 cross 4. So that problem of losing the shape is solved. Now if I talk about the second problem, that is the corner pixels are not really going to give you a lot of information because less time we are doing the convolution over there. What I'm trying to say is, let's just imagine that you are having a 2 cross 2 filter. Okay, let's forget we are having a 3 cross 3. Just assume that you are having a 2 cross 2 filter. So the first time you're going to put your filter on top of your input image, forget about the padding also, okay? It's going to be over 0 to 9. So every 4 pixels are getting convolved with the filter. After that, because let's say the stride value is 1, you're going to shift your filter 1 unit to the right. Now it's going to get convolved with this 2, 2, 3, 3. So you can see that this 0 was convolved only once. Even 9 is convolved till now only once. But this 2 and 2 are convolved more than once. After that, let's say this 2, 3, 2, 3 is done. I again shift it 1 unit to the right. It's now on 3, 4, 3, 5. So again, this 3, 3 are getting convolved. So even this is convolved twice. 4 and 5 is again convolved only once. But now because the stride value is 2, the stride value is 1, I'm going to shift 1 unit towards the bottom. And now it's going to be 9, 2, 2, 2. So this 2 is convolved thrice, 9 is convolved twice, this 2 and 2 is convolved for the first time. Then again shift it to the right, again this convolution will happen over here, shift it 1 to the right, again this convolution is going to happen for the one time. So over here 5 is going to be convolved twice. Just look at this 0 and 4, they got convolved only once. So we are not really able to get a lot of information from the edge pixels. And similarly, it's going to happen even for the bottom pixel over here, that is 3 and 9. And if you are adding a padding layer, and now if you do 0, 0, 0, 0 on the first time, and then if you do on 0, 0, 2, 0, then on 0, 2, 3, 0, 0, 3, 4, 0, 0, 0, 4, 0, then 0, 0, 9, 0, then even again over here 4, 0, 5, 0, the edge pixels are also now getting more than one convolution operation. And therefore now we are getting a better insights even at the edge pixels. So you need to really figure this out, that if the image that you are having in the training, if there are something really very fruitful that your model needs to know that what is present on the edges, you can always go with the padding layer. And in the other case, where you know that the output must be of the same shape as the input image, then even in that case, you can go with the padding layer. So that was about the importance of the padding part. So yes, that's it about this whole video over here, guys. I hope that by now you are having a clear-cut idea about what are the strides, padding, and what are the importance of having them, and in what different types of scenarios, what type of strides and padding we should use. Now, if you are thinking that the convolution operation is done over here, no. There are a lot of things that is dependent on the convolution layer, guys. We're going to spend a lot more time on that. And in the next video, I'm going to show you how the output shape is going to look like after performing convolution operation with some kind of filters. So stay tuned for that.